Hello friends, in this video I want to discuss about event loop in JavaScript. So when I was learning, I thought to myself, how does JavaScript actually work? And I was not sure enough. I had heard about V8 but did not know what that actually meant, what that did. I also heard things like single-threaded callbacks. How do callbacks work? So I started a journey of reading and research, experimenting in browser, watched YouTube videos, etc. So 3 months passed and I think I get this. Therefore, I want to share with you all today in this video whoever are new to JavaScript, it will be helpful to understand why JavaScript is so weird when you compare it to other languages. So first of all, we are going to start with the looking at the JavaScript V8 runtime engine. Okay, so let us just check it out first. So for that, let us just open it here, or instead let me just open it. So this is the JavaScript engine block diagram. So in this block diagram, what we see is memory heap, right? Here it is memory heap. This is where all memory allocation happens. Then we have call stack, where all function calls resides for execution from top to bottom. Then we have web APIs. We have these things called web API, which are extra things that browser provides. So in this category we have DOM, document object model. You might all have heard about this. You might be familiar. AJAX, that is asynchronous JavaScript request, right? Network request. Timeout, things like, right? We have this timeout API also. So we have this mythical event loop and the callback queue also. I am sure you have heard some of these terms before, but maybe you don't quite understand how these pieces pull together. So I am going to start from the beginning. Some of this will be new. Some of this might be new to people. Other people will get this. So JavaScript is a single-threaded programming language, single-threaded runtime. It has a single call stack. As you can see here, it is a single call stack. So that's what a single thread means, right? It is a single call stack, therefore single thread. So let's try and visualize that just to get our heads around what that means, right? So here is our example code to understand the call stack, single most call stack in the engine, right? V8 engine. So if we step into a function, we put anything a function is going to get pushed here, right? So the starting point of any program is the main function. You all know this, right? We have all studied in various programming languages earlier also in our education, right? So if we step into a function, we put something on the stack. If we return from a function, we pop off the top of the stack. That's all the stack can do. Now there is kind of a main function, right? Like the file itself. So we push it onto the stack. Then we have some function definitions, as you can see. So finally we get to the print square. So after some function definitions, we get here, right? As you can see, we get here print square. So now what happens after we get to the print square? So print square is a function call. Print square is a function call in which, so we push it onto the stack. Immediately inside print square, we push it here, and immediately inside the print square, what happens is, immediately inside print square, push onto the stack, which calls multiply, which calls inside the print square. As you can see, another function has been called, and inside this square we call multiply function, as you can see. And this happens when each time whenever the function call happens, like this. Now after then, when no function call exists, the execution begins, and the first line executes is the multiplication of a times b and returns. So we pop the element out of the stack that is on the top. So we pop this element out, you can see, we popped it and returns to the function call. So here it returns. So what happens here? Nothing, no line is there, anything else, no, nothing is there. So we just simply return the result. We return the result. So this is going to disappear. Yes. Now what remains? Print square function remains. Here return happens. Now here whatever the returned value here is, that is the multiplication part, is going to be initialized to this variable squared, and it is going to get console log. So that is going to happen. See this stack. Yes, it did, because that was also a function call. Console.log is also a function call. So therefore we get the function call. Finally, no more code to execute, because by now observe carefully that we do not have return statement here. By default, if no return statement has been mentioned, the JavaScript engine is going to, the interpreter is going to by default return. So here return happens and pop the element pops out. Nothing remains in the stack. The program has been finished executing. That's it. So this was a visualization of call stack. Does that make sense to you? Right? So now let us see the video clip of the stack trace. What the stack trace is, let us see. So for that, this is the example for understanding call stack trace. So let me fast forward. Yes, we have got the stack trace. This is the stack trace. Now see what happens in this code. We have function definitions. Yes, so this, after the function definitions, we have this function call. So call stack has been getting functions one after the other. So like here, as soon as this function has been called, inside this stack, the function code has been pushed. What again function call? It goes to this function, right? This function call is again calling this function. So the stack gets one by one filled up, and then there is no other function call. So therefore the next line has been executed is the error throwing. This is how we throw errors in JavaScript. So we get here uncaught error, oops, and it also shows us the trace of it, from where it originated, from where it has started, and where the origins is. So the origins are, currently it has started from this function foo, and the origins are base function, right? So this is the stack trace. So this is how stack trace is. Now let us see the what if we have this function like this and we are calling it again and again infinitely. What happens? Yes, browser has the solution for that. It is smarter than us. So let us see what happens. See, as you can see, maximum call stack size, actually it just terminates the program. Okay, it does not entertain further execution. So the browser has set a limit of 16,000 times the stack size. The stack size is set to 16,000. Above 16,000, the termination of program happens, and the error has been thrown by the browser, right? The error gets thrown by the browser. We get this range error. Yes, you might have encountered when you were studying or whatever, you might have encountered this range error earlier while studying, while developing any project. Okay, so this is all about range error. Now let us move further. This was all about call stack. This was just basic. I want to explain you what actually the call stack is, because this is fundamental. Okay, it is very important. Now we will move further. Yes, so yes, now blocking. So blocking the main thread. What happens when things are slow? What happens? So now JavaScript is a single threaded programming language. As I told earlier, it is the code execution happens synchronously, one step at a time, one after the other. One by one network request happens slowly. So why this is a problem? Okay, why this is a problem? So just observe this. If this network request is too slow, it is going to wait until the response is received, and this is not the desired behavior we should expect. So as you can see, it gets kind of slow, and this slow speed is not going to be get entertained in such dynamic fast growing industry, right? When we have fast growing applications, when we have so fast ultra speed high applications, highly efficient applications in the industry, right, various projects, we cannot have this like this behavior entertained. So fortunately we have the solution, but first of all let us just understand the problem first. Okay, why this slow behavior is not going to work further? Why? So first of all let us move on. Why this is a problem, we have to understand, because we are running our project on browsers. Okay, we are running this on browsers, and if that behavior is going to happen in the browser, the interactivity is going to break. Just observe this. I am going to explain you by this example. You are going to understand this very clearly why this is a problem. Just observe. See, so I am zooming it. I have clicked the run button. The code has been started executing. We are console logging various get request API response, so like requesting foo.com and whatever. So we are currently requesting. As you can see, while this program process is happening, the network request is happening, I am not able to interact with any part of the DOM, document object model, that is with the application. See this, it has been rendered in that state, right? I am not able to click further, I am not able to interact. Now this is a very big problem. It seems like it has been hanged, the application has been stuck, right? See, now the response has been came. So this process is slow, of that is synchronous API calls are slow, because the requests are sent to the servers are very far, servers might respond with a delay, the request might reach with a delay. So there is a lot of delay there, right? Because this is all happening on a network, so we cannot expect it very that we will receive the response very quickly. So therefore this is going to take time. So this, if we are going to develop projects and we are going to make data request, we need a way of dealing with this problem. So I am going to show you the solution. We have understood the problem. Now let us see the solution. So let us see, because we are running this code in browser, I am faking this out while with a big while loop, because it is synchronous. I basically while loop for 5 seconds before continuing. So if I open up the console, we can see what happens with the request of why this is happening. I can't do anything, right? Even the run button has not finished rendering. The fact that I clicked it, the browser is blocked, it is stuck. I can't do anything until those requests complete, and that all hell breaks loose because I did some stuff. It figured that I would have done it. I could not actually render, couldn't do anything else. That because if that call stack has things on it, and here it has got this. So we have got the synchronous request. The browser can't do anything else. It can't render, it can't run any other code. It is stuck. Not ideal, right? Not ideal, right? So if we want people to have nice fluid UIs, user interface, we can't block the stack. Now we understood the problem. Let us see the solution. So let us see the solution. The solution is asynchronous callbacks. Okay, so now asynchronous callback is the solution. Here, okay, we'll straightly move on to the code. Basically, set timeout function is a part of a web API to demonstrate asynchronous network request, asynchronous programming. So here this is the solution, that how after 5 seconds we are getting something, and we are still able to interact with the application in that time frame. That is the main solution here. The browser is not blocked, it is not stuck. So asynchronous callbacks with regards to the stack we saw before. How does this work? Let's run the code. So we run the code, we log the console, yes, the console log, and let us understand what it is. So if you are going to see, what happens is we are going to console log hi here. We are going to execute, the engine is going to execute this, and somehow it is going to disappear from the stack. We are going to console log JS conference here, and the stack gets empty. It does not have any other function calls further, but somehow after some seconds, magically the stack gets the function callback function into the stack somehow, and console log happens. So how does this happen? How does magically it got pushed into the stack? So there we have the event loop into the picture, okay, and concurrency. This is basically where the event loop comes in, right? So I have been kind of partially lying to you and telling you that JavaScript can only do one thing at one time. That is the case most of the time. The JavaScript runtime can do only one thing. It can't make the request while you are doing other code. It can't do a set timeout while you are doing another code. The reason we can do things concurrently is that the browser is more than just the runtime. I have told you earlier, just remember it. So remember the diagram. The JavaScript runtime can do one thing at a time, but the browser gives us the other things, okay. Web APIs, as we call it, that these are so effectively threads you can just make calls to, and those pieces of browser are aware of this concurrency. So set timeout API is an API provided to us by the browser. It does not live in the So set timeout is an API provided to us by the browser. It does not live in the V8 source. It is the extra stuff we get in that we are running in JavaScript runtime. The browser kicks off a timer for you, okay. Just let us visualize it in our example, okay. The browser kicks off a timer for you, and now it's going to handle the countdown. So here console log happens. Yeah, we have the set timeout into the stack. What happens here? Somehow magically browser provides this. So browser timer web API part. So timer starts, callback function is there. So as you can see, it disappeared. Code processes further, log happens, stack gets finished. Main function gets, okay, main function is also returned, and stack is empty now. Now in some time we are going to see that somehow it has finished 5 seconds and it has been pushed into task queue. Here all the callback functions are queued for execution. Now the main task of event loop comes into the picture. Basic simple task of event loop is look at the stack, look at the task queue. If the stack is empty, just take the program, take the callback function that is there in the queue and push it into stack. That is what the event loop does. That is the simple job of it. So let's see. As you can see, the event loop pushes into this stack and function execution happens. And yes, we get the log. Yes, so this is all about event loop. As you can see, the job of event loop is very simple. If the stack is empty, it takes the first thing on the queue and pushes it into stack, which effectively runs it. So here we can see that now the stack is clear, there is a callback, and that happens, the process happens, right? Yes, so this is all about event loop. Now just understand, if we set the timer to 0 seconds, so what we might expect is that we get the console log, right? We get the console log hi, and then we might get the console log there, and then console log JS conference. But that is not the case, because as soon as this function call happens, right, it is basically handled by the web API. So the process goes here actually, and there the timer starts, but the timer immediately expires, but the process is that it has to push into the task queue, right? Yes, my friends. So just the callback function gets pushed here, does not immediately get pushed here. Therefore we are not able to get the console log of there immediately. And obviously if this has been pushed into the web API, the next part that gets into the stack is the console log JS conference. So this gets executed, after which this gets emptied, and then the callback function event loop pushes it into this stack and we get the console log. This is very simple, right? That's all about the event loop. I hope you have understood the topic, the fundamental. Thank you very much for watching this video.